Hi everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying straight lines lecture 3. So we'll be continuing with our locus examples and we'll be seeing few other concepts. So let's start with the first example. A rod of length, let's say L, slides with its ends on two perpendicular lines. Find the locus of its midpoint. So first thing to notice over here is it's given two perpendicular lines. Whenever such condition is being given, you have to assume that these two perpendicular lines are nothing but y and x-axis. Okay, so you don't have to take such kind of perpendicular lines, or you don't have to take towards here condition towards here. You have to take towards the right side only. Okay, so that is the basic assumption you have to take. Now let's try to draw the x-axis and y-axis. Let's say this is our rod and this is the midpoint, and we have to denote it with h and k. Okay, now this length is L. Let's say this point is a comma 0 and this point is 0 comma b. Now with the help of midpoint theorem I know that h equals to 0 plus a by 2, right? So basically a equals to 2h. Similarly, b plus 0 by 2 equals to k. So that would give me b equals to 2k, right? Now, what is the geometrical condition over here? We have assumed the point. The first step we have done, we have assumed the point. And now what is the geometrical condition? Geometrical condition is that it's sliding. So basically it means that it's not losing contact from this wall and neither from this ground, right? So that means if I consider this triangle, this length is L, then whatever be the coordinates of these 2 points, variable points, the eventual length of the hypotenuse would be L only, right? So that is our geometrical condition. So let's try to use that condition. So we have got coordinates over here, 0 comma, this is 0 comma 2k, and this is 2h comma 0. So basically this length is 2h and this length is 2k, sorry, 2k. So 2k square plus 2h square equals to L square with the help of Pythagoras theorem. So basically under root of this equals to L. So this is our final equation, or you can just write it this way only. And now replace k with y and h with x. So 2y whole square plus 2x whole square equals to L square. So this is the equation of our locus. So we started with h and k, we used the basic conditions, then we applied the geometrical condition. Now let's look at this question. Let A and B be the vertices of a triangle ABC. If the centroid of this triangle moves on the line 2x plus 3y equals to 1, then the locus of the vertex C is the line. So basically A, B, C, this is a triangle, and C point is the variable point. So A point is fixed, that is 2 comma minus 3. B point is also fixed, that is minus 2 comma 3. Now C point is h comma k. Okay, so over here, how can we visualize the situation? So basically, G centroid is over here, and it is being said that centroid of the triangle moves on the line 2x plus 3y equals to 1. But how does it move? It moves because let's say that these are the points hk and these are the variable points. And let's say now our triangle looks like this one because A and B are fixed. Now this is h dash and k dash. These are some different points for C, right? So as this C point is moving, this G is moving along 2x plus 3y equals to 1 because centroid is this plus this plus this by 3, and if this is moving, so centroid is also variable. So that is how we have to visualize the situation. Now let's say G has the coordinate x comma y. So x equals to 2 plus h minus 2 by 3, that is nothing but h by 3. Similarly, y equals to minus 3 plus k plus 3 by 3, that is k by 3. So we have got coordinates of G, and now these coordinates satisfy this equation as well because it's moving on it. So 2x plus 3y, so basically 2 times h by 3 plus 3 times k by 3 equals to 1. So this is our equation of locus. Okay, now let's see one more question. Vertices of a variable triangle are 3, 4, 5 cos theta, 5 sin theta, and 5 sin theta minus 5 cos theta, where theta belongs to our locus of its orthocenter. Now we know that we don't really know any kind of formula, any kind of standard formula for orthocenter, and even if it was there, we can say for sure that it would have been very difficult to apply, right, with the help of basic concepts. Now we also know one concept of OGC 2:1, right? We know this concept. So we have to find out the locus of orthocenter. So if by any chance if I get to know the value of G and C, then my work would be done, right? Because then I can apply the concept of 2:1 OGC, and then I'll be able to find out the coordinates of O and basically the locus of O. Somehow I'll be able to find some kind of relation over there. Now over here nothing has been given, but one thing I can observe is the origin 0, 0 is equidistant from all these 3 points. So if I try to calculate distance of this point with origin, that would be 5. If I try to calculate distance of this point with origin from origin, that would be again 5, and so for this case, right? So basically I can conclude that basically circumcenter is origin only. So circumcenter has the coordinates of 0, 0. Now centroid is easy. For centroid, what we can do, we can find out by adding these 3 and dividing by 3. So gx would be 3 plus 5 cos theta plus 5 sin theta divided by 3, and gy would be 4 plus 5 sin theta minus 5 cos theta divided by 3. So we have got the coordinates. Now let's use the condition O, G, and C. This is 2 and this is 1. So basically these are the points. This is dividing the ratio 2:1. Now O is basically h comma k, because that is the variable point we have to consider for finding out the locus. And this is 0, 0. So based on these 2 points, we can find out the values of gx and gy. So let's call. So from this, gx equals to 2 times 0 plus 1 into h divided by 1 plus 2. That would come out to be h by 3. Similarly, gy would be 2 times 0 plus 1 times k divided by 1 plus 2. That would come out to be k by 3. So we have got the values of gx and gy from here as well, and we have got the values of gx and gy from here as well. Now we eventually know that in the equations we don't have theta, so basically we have to eliminate theta, right? So we have got 3 plus 5 times sin theta plus cos theta divided by 3, that is equals to h by 3. Cancel out 3. So basically this is equals to h. And similarly 4 plus 5 times sin theta minus cos theta equals to k, because of the cancellation of 3. Okay. Now we have got these two equations. So this is first equation, this is second equation. What I'll do, I'll subtract both of them first and add both of them. So by subtracting, what I'll be getting, minus 1 plus 5 times, and sin theta gets cancelled out, I'll be getting 2 times cos theta, 2 cos theta equals to h minus k, right? So basically 10 times cos theta equals to h minus k plus 1. So this is our third equation. If I add both of them, I'll be getting 7 plus 5 times 2 sin theta equals to h plus k. So basically I'm getting 10 times sin theta equals to h plus k minus 7. If I square 3 and 4 and add them up, I'll be getting 100. Basically 10 square cos square theta plus 10 square sin square theta. So basically I'll be getting 10 square as common, and sin square theta plus cos square theta is common. That is 1 only. So 100 equals to h minus k plus 1 whole square plus h plus k minus 7 whole square. So this is the final locus. So if I want to replace it with x and y, then I'll be getting x minus y plus 1 whole square plus x plus y minus 7 whole square equals to 100. So x minus y plus 1, x minus y plus 1. Yeah, D is the correct answer. This one. Now let's talk about slope and inclination. So basically, let's say these are our x and y axis, and let's say this is one line segment A and B. So it's something of this sort. Okay. So this is our line segment AB, and I have extended this towards x-axis. Now, if I try to draw perpendiculars from both the points, basically from B, I'm dropping perpendicular to x-axis, and I'm from A, I'm dropping perpendicular towards the perpendicular of dropped from B, right? So this is perpendicular. Now this angle is theta, and I can see that this is a right angle triangle. So let's say A has the coordinates of x1, y1, B has the coordinates of x2, y2. And if this is horizontal, so basically this angle would be theta, corresponding angles basically. Now this distance is y1, this distance is y2, this distance is x1, and this distance is x2. So basically this distance is x2 minus x1, and this distance is y2 minus y1. Now if I try to write the slope, that would be y2 minus y1 divided by x2 minus x1, and that is nothing but tan theta. So basically, if I measure the angle in the counterclockwise direction, and that is theta, then tan theta is slope only. And slope also can be written in this particular format. Okay. So this is the inclination and this is the slope. This is the slope and this is the inclination. Now let us talk about condition of collinearity. Let's say we have this line and we have 3 points on it, A, B, C. So if 3 points are lying on a single line, in that case, these 3 points are called as collinear, right? Now the first condition, how to judge if any 3 points are collinear or not, the first mathematical condition would be the slopes of AB and BC would be same, right? Because these 3 points are collinear. So slopes of AB and BC should be same. So let's say this is x1, y1, this is x2, y2, and this is x3, y3. So that would mean if I try to write the slope of MAB, so MAB would be y2 minus y1 divided by x2 minus x1, and MBC would be y3 minus y2 divided by x3 minus x2, and both of them should be equal, right? So this is our first condition. Now the second condition would be, so let's say we have these 3 points A, B, C, and what I'm trying to do, I'm trying to squeeze A towards the line BC. So this was a triangle, but I'm pulling down this particular vertex towards BC. I'm taking it closer, and I'll reach a point where A is also lying on this particular line, right? This particular side. So that would mean its area would keep its area would keep on reducing, and eventually when it's on the line, its area becomes 0. So that is what written over here, and we knew that this delta meant, so basically trying delta was 1 by 2 times x1 y1 1 x2 y2 1 x3 y3 1. So this was the area of triangle, and now this has become 0. So if this has become 0, in that case all 3 points are collinear. So x1 y1 by x2 y2 and x3 y3 are collinear if delta is 0, basically if area is 0. So you have to solve this determinant. If the value of this determinant is 0, then these 3 points are collinear. Okay. Now the third condition is, again, that is very intuitive, AB and BC. Now let's say B point was over here. In that case, AC length would be something, but AB plus BC would be bigger than AC because of the triangle property. In case of a triangle, we have sum of any two sides. AB plus BC is always greater than AC. Always. You take any two sides and sum two of them, that would be greater than the third side. That is the property of a triangle, right? Now, if they are equal, AB plus BC equals to AC, in that means that is not a triangle. That the third point is also lying on the line only. So basically, these 3 points are collinear. Okay. Now the fourth condition. So that's a little trickier one. So let's say we have these A, B, and C. Now what I'll be doing, this point is x1, y1, x2, y2, and x3, y3. I'll try to find out the ratio in which this particular point is dividing internally A and C, right? So let's say this ratio is m is to n. And first I'll try to find out the ratio with the help of x coordinate. And then I'll try to find out the ratio with the help of y coordinate. If both the ratios are matching, that means this particular point is lying on this particular line. Basically, these 3 points are basically collinear, right? Otherwise, if they're not matching, that means they're not collinear. Okay. Now let's look at this question. This question is actually pretty standard one. And what we have to do is we have to find out the slopes with the help of these 2 points. And we have to find the slope with the help of these 2 points. And we have to equate them and find out the value of A. So that is you have to do for the condition of collinearity. Or you can do anything else. You can use the determinant form as well. But slope one, it would be better over here. Okay. So I'll leave that for the homework. And today's lecture was still here only. And let's meet tomorrow for the next lecture. Thanks for watching.